Ahoy there makers! Let's take a closer look at the PicoVision. So the PicoVision is a microcontroller based digital video stick for bold audio-visual adventures. It features a dual RP2040, that is two separate RP2040 microcontrollers and a conveniently HDMI shaped output. So a nice full-size connector. You can make glitch art, retro-inspired games, demos, digital signage, and so much more. It features this dual RP2040 controllers. One acts as the main CPU and the other as a GPU, graphics processing unit, for taking care of the display. This frees up the Pico W, aka the main CPU, for all the fun stuff. So crunching numbers, generating cool graphic effects, and doing really interesting stuff with the Wi-Fi and Bluetooth. You can output visuals to almost any HDMI display, be it a standard monitor, giant projector, or a tiny little panel for building a prop. You can get started in minutes, everything's preloaded with MicroPython, no soldering required, you're ready to go. So you can make some homebrew games, you can make digital art, recreate beloved demos from the 80s, you can make screensavers or Winamp visuals, you can visualize data, you can subvert advertising billboards, you can emulate CFAX, because why not? Or you can whip up some last minute signage for your cyber night market. So let's have a deeper dive on some of these features. So like I said, it contains the Raspberry Pi Pico W, which is a dual ARM Cortex M0 Plus running at 133 MHz with 264K of RAM. It has 2 megs of QSPI flash for storing your programs. It's powered and programmable by the USB Micro B connector, and it has 2.4 GHz wireless and Bluetooth 5.2 on board as well. Now the GPU processor is an additional RP2040, and this is another dual ARM Cortex M0 Plus running at 133 MHz up to 264K of RAM. It can actually run at higher resolution modes if you overclock the GPU, and it connects to the CPU as an I2C device internally. Now there's an additional 2 times 8 meg of PS RAM, and this means we can store frames off the screen ready to be displayed very, very quickly, and it can switch between those very, very fast. Digital video output over HDMI, which means that we can plug this, like I said, into any monitor that will take a HDMI input, and it has a digital to audio line converter as well, and it has a PCM 5100A DAC for line level audio over I2S. Very technical stuff there, but essentially it just means it does audio out using the I2S protocol, and it has the 3.5mm jack for doing that as well, stereo jack. Has a micro SD card slot as well, so you can store all your graphics, sprites and things on there. It has 3 user buttons as well, 1 wired to the CPU and 2 for the GPU. Has a reset button for really convenient resetting of the device, a status LED on the GPU, and it has a Quest Stemma QT connector as well, so you can plug in additional boards and connectors and sensors and things. Comes fully assembled, so there's no soldering required, and there's some spare extra pins broken out on the unpopulated headers. These do require some soldering. And it comes with, of course, the C++ and MicroPython libraries from Pimoroni as well. So let's take a look at the accessory pack as well. So this is an optional pack that you can buy along with the PicoVision. So it comes with a PicoVision board, a 50cm HDMI cable for plugging into a monitor, a USB-A to micro B cable for programming the CPU, a micro USB splitter cable for connecting the USB accessories, such as a keyboard if you wanted to play Doom, for example, and some Velcro pads so you can actually mount this behind your monitor as well. Highly recommend getting this. And if you want to look at the schematic, we have the pins and dims, as they say. You can look on here, we've got the micro SD card, the Quest connector at the top, we've got a little DAC chip, got the line out, the HDMI connector. On the bottom right there, we have all the breakout pins, so you can solder additional headers on there if you want to. You can debug the CPU or GPU. And on the left-hand side there, we've got the power in as well. And there's a whole bunch of mounting holes as well, so you can see the regular mounting holes for the Pico as well. There we go, and then the mount, didn't drop it. And then on the other side there, you can see we have the mounting holes for the Pico. A printable PDF is available, and the schematic will be coming shortly too. So how does this work? This is really, really ingenious. So PicoVision features 2 RP2040s, one for the Pico W, which is the main CPU, which is the main one on the board, and it also has one for the GPU to produce the high resolution, particularly for a microcontroller, digital video output by swapping the contents of 2 physical PS RAM frame buffers back and forth between them. So very, very clever use of frame buffers there and 2 processors working in tandem. So the 2 PS RAM acts as a front and back buffer. The CPU, the Pico W, writes the CPU, the PicoW, writes one while the GPU reads the other one, and applies some hardware effects to generate the digital video signals. And the ingenious firmware for PicoVision's GPU has been developed by considerable help from longtime collaborator and software wizard Mike Bell. So connecting additional breakouts, so we do have the Quest connector on board here as well, the quick Stemma QT connector, and that means we can plug in additional sensors. We're going to have a look at the CO2 sensor in a minute on the demo. You can have all kinds of additional breakouts on there. If your breakout has the Quest connector on board, you can simply plug it straight in using the JST-SH to JST-SH cable. To see a full product page of all the different types of breakouts that are currently compatible with our Pico board range, check out the product page below. Okay, so some things to note. So there is a list of all the supported resolutions for the product on the product page and some caveats. Note that some modes may require overclocking the CPU and other shenanigans. By default, the reset button resets both the CPU and the GPU, and if for some reason you want to be able to change that, there is a cuttable trace on the back of the board as well. A little cuttable trace just there. We've broken out some spare pins as unpopulated headers along the bottom of the board, and you can find the serial wire debug pins for both the CPU and GPU there as well, plus a number of unused GPIO, because why not? Our software doesn't support audio over HDMI, but if you're brave enough to pass I2S audio data from the CPU or the PS-RAM buffers to the digital video connector, the board is wired to support that. As with all of our Pico aboard range, it comes with a PicoW aboard. So there's a regular Raspberry Pi PicoW surface mounted to the board. This means you get all the advantages of the RP2040 microcontroller, a speedy fast dual core ARM processor, a dynamic growing ecosystem, and it really is growing now, of all different methods for experimenting with. And most excitingly though, the PicoW comes with Wi-Fi and Bluetooth connectivity. So this means you can communicate with each other devices, and of course get data from the internet. Okay, demo time. So looking forward to showing you this. So I've got, if I go to my overhead over here, I've got the PicoW plugged in, I've got one connected to my computer, and I've got the other end connected into the same computer, but using a capture card. I've also got this little CO2 connector connected up by the JST-SH connector. So if I go to this view here, this is what happens when we reset the board. So if I just press the reset button here, we can now see that the board comes to this menu system, and we can use these buttons here to move up and down. So if I go, for example, to the bouncing logo and I press this Y button, it will now load the bouncing thing. So let's go full screen to see that. And we can also press the Y button, I think it's the Y button, to make additional faces appear. There we go, we've got, I think we can have up to 4 pirates bouncing around at the same time on the screen, and it seems to handle that fine. Let's see, there we go, 4 all on the screen at the same time. Okay, that's loads of fun. I can simply just press the reset button to get back to that main menu. Now I did also want to show you, if I load up Thonny in this little screen at the bottom here, I know it's a bit small to see, but I just wanted to show you that I can actually stop the code. I can enter the regular REPL, and we can also run some of these demos manually. So for example, if I want to run the CFAX Python program, let's run this one. This one will emulate an old-fashioned CFAX page when we used to have CFAX and was it the Oracle on the other channels. So there you go. So this has actually grabbed some headlines live from the BBC website, I believe it is. Let's have a quick look on the code. So yeah, so bbcci.co.uk news/RSS. So it's just grabbing some world headlines there. And you can also see, if we go full screen there, what that looks like. We've got the time and the date at the top of the screen, and it's sort of ticking by. You can also see it says Pirate Monkey Robot Ninja on the bottom as well. This is what the Pimoroni stands for, if you didn't know that already. Okay, let's go back to the main menu again, and let's now try another demo. So, right, let's try Hello World. This is a very, very simple one. This will simply just display Hello PicoVision on the screen. Let's do the next one, which is Hello World Rainbow. Let's try this one. You can see all the different rainbow colors there. And then the next one is some vector graphics. So let's try this. So this is pretty neat because it's really smooth. It uses some anti-aliasing of the font there, so you get this nice sort of smooth effect, and it'll sort of rotate around there and do all kinds of clever stuff that you can do with vector images. That's not as easy to do with pixel graphics. So there we go, that's the vector ones. Let's try now, oops, floppy bird then again. Let's move down. Let's try the CO2 program. So this is using this CO2 sensor that I've got connected there. So it's just waiting for the sensor to become ready. And I'll try and breathe on the sensor to try and get the readings up a little bit. It's a little bit slow to refresh, simply because it's designed to run all day, taking readings every couple of seconds or so. So let me just try and breathe on this for a second. Right, I've given it some nasty breath there. Let's see if the actual amount changes on there, parts per million. So it does take a little bit of while. And there's also a little graph there that's being displayed just above my head there. You can see the lines sort of changing a little bit. That can use the Quest connector, and it's actually connecting over I2C over the Quest connector as well there. So let's jump back out that one. Okay, let's see what else we've got on here. So we've seen the bouncing logo. The clock is pretty cool. So this looks really nice at a high resolution. I've got this, like I said, quite low resolution just because of my cheap capture card. So just need to wait for that for a moment to grab the time from the internet. So I've had to create a secrets.py, which has got my Wi-Fi SSID and Wi-Fi password in there. So nice smooth vector graphics, and they look even nicer at the high resolution. It's just trying to scale this down to the resolution that I've got available by capture card. And the one I think is the best demo to show you on here today is the Snakes and Ladders one. So let's go down to that. Snakes and Ladders. This one looks really, really nice. So let's wait for that one to, there we go. You can see there's a little dude at the top, and he's just touched one of the snakes, and he's going down the ladder there. He just touched the snake again. So I'm actually not controlling this. This is just sort of running a demo program. We can see how smooth that looks. That looks pretty nice. Very sort of retro 80s platform game-esque, I think. Cool. So let's reset that one, and then let's go have a look at some of the other demos we've got. I think there's some Starfield ones which are pretty cool. Starfield. So this one is like something from Star Wars or Star Trek. So the little objects are getting closer as you zoom into the screen. And there's a colour version of that one as well. There we go, got a colour version as well. So if you like this kind of video, you like electronics, Raspberry Pis, Picos and so on, MicroPython, I have an entire YouTube channel dedicated to such things. So if you go over to youtube.com/KevinMcAleer28 or visit kesrobots.com, you'll find all kinds of videos there. I most recently did one about the Raspberry Pi 5 and the projects that you have to make specifically for the Raspberry Pi 5, so be sure to check that one out. So I hope you enjoyed this short video, and I shall see you next time. Bye for now.